Welcome to educator.com. This lesson is about properties of exponents. In this lesson, you will learn to multiply and divide expressions with exponents. The applications for this are performing calculations involving large numbers, such as finding the distance between planets. Also, you might perform calculations involving very small numbers, such as finding the size of atoms. Let's review the vocabulary. An exponent is the number of times a base is used as a factor. So in 3 to the 7th power, or 3 to the 7th, the 7 is your exponent and the 3 is your base. And the power is an expression using a base and an exponent. So in 3 to the 7th, this entire unit is your power. So as a quick recap, this is your base, this is your exponent, and the base and the exponent together is your power. Multiplying powers with the same base. To multiply powers with the same base, you're going to add the exponents. So basically, if you have a to the n power plus a to the nth power, it's going to be a to the m plus n. For an example, if I had 3 squared plus 3 cubed, I would add the exponents and it would be 3 to the 5. So 2 plus 3 is 5. Now let me illustrate this by writing it out. This is 3 times 3, and this is 3 times 3 times 3. And if we count that up, we have 1, 2, 3, 4, 5. 3 to the 5th. It's often difficult to keep track of the rules for exponents since they will also be different for raising a power to a power. So a good way to keep track of the rules is just to write it out if you forget. So in this case, if you're not sure whether you should be saying 2 times 3 or 2 plus 3, once you write it out, 3 times 3 and then 3 times 3 times 3, you see that if you count it up, there's 5 of them. So that would help you figure out the rule. Let's try multiplying expressions with exponents. So remember that you keep the base the same and you multiply and you add negative 3 plus 2. So it's going to be negative 3 plus 2, which equals 7 to the negative 1. And if you remember from a previous lesson on exponents, this could also be written as 1 over 7. Here we have, there's an imaginary 1, so negative 4, 1 plus 8, equals negative 4 to the 9th. Be careful that the negative sign is inside the parentheses. That means that the exponent is also repeating the negative. Don't leave it outside the parentheses. And then with a variable, we have m2 plus 12, which equals m to the 14th. So we were just adding all the exponents. Negative 3 plus 2 is negative 1, 1 plus 8 is 9, and 2 plus 12 is 14. Let's try dividing powers with the same base. If you think about when you're multiplying, you're adding the exponents. When you're dividing, you're subtracting the exponents. So if you have a to the m over a to the n, that actually becomes a to the m minus n. And that's when a is not 0, because remember that a cannot equal 0 here, because you cannot divide by a 0. That would be undefined. So the rule is as long as a, the base, is not a 0. Let's try dividing expressions with exponents. The distance between the sun and a comet is about, let's make that the times, because this is scientific notation here. The distance between the sun and a comet is about 2.8 times 10 to the 8th miles. Light travels about 1.1 times 10 to the 7th miles per minute. Use the formula time equals distance over rate to estimate how many minutes sunlight takes to reach the comet. Okay, so let's look at the formula. Time equals distance over rate. They tell us the distance is 2.8 times 10 to the 8th, so I'm going to substitute it in place of distance. 2.8 times 10 to the 8th. They tell us the rate is 1.1 times 10 to the 7th miles per minute. Notice the miles are going to cancel out and you're going to end up with minutes, which is what you're looking for. All right, so first what we're going to do here is divide the decimals, and then we're going to divide the exponents. So first, dividing the decimals, 2.8 divided by 1.1. This is just a plain old decimal division that you've done many times. Move the decimal, move the decimal. So 1.1, oh, we've already moved the decimal out. So 11 into 28, which is 2, 22, 8 minus 2 is 6. Goes in 5, which is 55, and leaving 5, which would be another 4. So it says about, estimate about. So instead of 2.54 and getting more exact, I'm just going to take 2.5 because this 4 tells me that the 5 is going to stay a 5. So when dividing the decimals, I got 2.5. And over here, let's take, remember that when dividing exponents, what you're doing is subtracting. So 8 minus 7 is 10 to the first power, but we don't need the first power. So once again, quick recap, you divide the decimal portion, just plain old dividing decimals, we got 2.5, and then you come and you divide the exponents portion. And the exponent portion, we just learned, is you subtract the exponents. 8 minus 7 is 1. So 2.5 times 10 to the first power, and you don't need that 1. So you put the decimal portion along back with the exponent portion. The distance between the sun and Earth is about 9.4 times 10 to the 7th miles. We want that to be scientific notation and that to be scientific notation. Light travels about 1.1 times 10 to the 7th miles per minute. Estimate to the nearest minute how long sunlight takes to reach the Earth. Use the formula T equals D over R. So time equals distance over rate. And let's put in substitution. We know that the distance is 9.4 times 10 to the 7th, and we've found out that light travels at a rate of 1.1 times 10 to the 7th. So just like before, we're going to divide the decimal portion. Can't divide with the decimal out here, so I'm going to move it over 1, move it over 1. So now it's 11 into 94, which will go 8 times, giving us 88. 14 minus 8 is 6. And if I'm going to put a decimal here and continue it, it's going to be 5. And if I continue, it'll be 4. So estimating, I'll say about 8.5 for the decimal portion. And look here, if we take 10, 7 minus 7 is 10 to the 0. And as you remember, any exponent 0 equals 1. So 8.5 times 1 will just equal 8.5. And so it'll be about 8.5 minutes for the sunlight to reach the Earth. Okay, so we have a base of 3.4 to the 4th times 3.4 to the 11th. Now remember, when multiplying powers, you keep the same base, do not multiply the base, and then add the exponents. 4 plus 11, 3.4 to the 15. 10x to the 7th over 2x to the 3rd. So just like before, separate the number from the powers. 10 divided by 2 is 5, and with the exponents, you subtract downwards. X, 7 minus 3 is x to the 4th, 5x to the 4th. The distance from the sun to Saturn is about 9.9 times 10 to the 8th miles. We want that in scientific notation. The speed of light is about 1.1 times 10 to the 7th miles per minute. Use the formula time equals distance over rate to estimate the nearest minute how long sun takes to reach Saturn. So we've got our time equals distance over rate. Our distance is 9.9 times 10 to the 8th. Our rate is 1.1 times 10 to the 7th. And that's going to give us our time. If you notice, the miles and the miles will cancel out, leaving us with minutes, which is what the question is asking for, to the nearest minute. So I'm going to divide these numbers, 9.9 divided by 1.1, move the decimal out, move the decimal out. 11 goes into 99 perfectly 9 times. So 9.9 divided by 1.1 is 9. And then now let's work with the powers. Remember that when you divide exponents, you're simply subtracting them. 8 minus 7 is 10. So it's going to be 9 times 10. And in this case, it's small enough you could say 90. So it'll take about 90 minutes for sunlight to reach Saturn. The sun's diameter is about 1.4, scientific notation, 10 to the 6 kilometers. Earth's diameter is about 1.3 times 10 to the 4th kilometers. How many times greater is the sun's diameter than the Earth's diameter? How many times greater is it? So if we divide, we'll find out how many little Earths can fit inside the sun's diameter. So let's take the sun, which is the greater one, 1.4 times 10 to the 6th, and divide by 1.3 times 10 to the 4th. I'm going to divide the decimal portion first. 1.4 divided by 1.3, move it over, 13 into 14. It'll go one time, and 13 into 10 won't go. And so if I'm going to estimate, I'll just say this is about 1. Now here with the powers, I have 10 to the 6, 6 minus 4. 6 minus 4 is 10 to the 2nd. So 1 times 10 to the 2nd. So how many times greater is the sun's diameter than the Earth's diameter? 1 times 10 to the 2nd. 10 to the 2nd is 10 times 10, which is 100. So if we were to say 1 times 100, it's 100. So how many times greater? It's 100 times greater. Thank you for watching educator.com.